All right, so we're going to go over a stoichiometry problem here. And this problem says when aluminum is mixed with iron 3 oxide, iron metal and aluminum oxide are produced along with a large quantity of heat. What mass of iron 3 oxide will be needed to produce 25 grams of iron? So the first thing we have to do is be able to write our equation in an actual formula instead of having it in words. So we know that we're given aluminum, and we know it's mixed with iron 3 oxide, and it says that iron metal and aluminum oxide are produced. So those are our products. So we have aluminum reacting with iron 3 oxide. Now we have to figure out what the formula for that is based on the fact that iron 3 we know has a 3+ charge and oxygen has a -2 charge. So if we switch those, we get Fe2O3, okay? And that reacts to form iron metal, which is just Fe by itself, and aluminum oxide. Aluminum has a 3+ charge because it's in group 13. Oxygen is -2 because it's in group 16. It needs 2 more to be happy. So if we switch those, we get Al2O3. All right, so the states of this: aluminum is a solid. Aluminum is a solid. Okay, and iron 3 oxide is an ionic compound, so it will be a solid as well. It makes iron metal, which would be a solid, and it makes aluminum oxide, which would also be a solid. And it says it produces lots of heat, which means more than likely the iron and the aluminum oxide would be molten or liquid to begin with, but they're going to solidify in the end. Okay, and then we need to balance this. So we have aluminum, we have iron, and we have oxygen. Okay, so on the reactant side we have 1 aluminum, and on the product side we have 2. On the iron on the reactant side we have 2, and on the product side we have 1. Oxygen we have 3 and 3. So the only thing that's out of balance is the aluminums and the iron. So if we multiply the reactant side aluminum by 2, that balances both sides, and if we multiply the product side iron by 2, that balances that one as well. Okay, so our balanced equation is 2 aluminums plus 1 iron 3 oxide yields 2 irons plus 1 aluminum oxide. Now I'm going to erase the balancing so that we actually have room to do the actual work we need to do. All right, so starting in on our problem with our givens here. We are actually given 25 grams of iron. It asks if that was produced, how much iron 3 oxide would be needed. So we're looking for the mass in grams of iron 3 oxide. Okay. Now, in order to do that, we have to look up here at the mole map. We've got grams of iron to start with, which means that we're up here on our mole map in mass in grams, which means that we're going to have to use molar mass to get to moles of iron, and then use our coefficients to go to moles of iron 3 oxide because we've got 2 different substances, and then finally use molar mass again to get the mass of iron 3 oxide. So this is a 1, 2, 3-step equation. So let's get started writing our equivalent statements. Our first equivalent statement is going to be the molar mass of iron. So 1 mole of iron, because it's always 1 mole for molar mass, is equal to blank grams of iron. And we just looked that up on the periodic table. The molar mass of iron is 55.845. Okay, and then to go from moles of iron into moles of iron oxide, we use the coefficients. 2 moles of iron equals 1 mole of iron 3 oxide. Okay, and then we need our molar mass of iron 3 oxide. And molar mass is always 1 mole. And this one we're going to actually have to calculate. So we have 2 irons. So that's 2 times 55.845. We have 3 oxygens. So that's 3 times 15.999. So that equals 111.69, and that equals 47.997, and then we add those two together to get our molar mass. And that equals 159.687. And we put that up in our blank up here. So now we have our 3 equivalent statements: moles to grams to get out of the grams of iron and into moles, and then moles of iron into moles of iron 3 oxide, and then moles of iron 3 oxide into grams of iron 3 oxide. So at this point we're ready to do our equation. So in our equation we have what we're given first, which is grams of iron. And so that means that we need to get out of grams of iron and into moles of iron. That's the first equivalent statement that we use right here. And then we need to get out of moles of iron and into moles of iron 3 oxide. And that is the second equivalent statement here, where we use the coefficients as ratios. And then we can get out of moles of iron 3 oxide and into grams of iron 3 oxide. Okay. And then at this point we can substitute in our numbers. So if we look at our givens, if we look up here at our given is 25 grams of iron. So we put in the 25 grams of iron. And then we look at our first equivalent statement for moles and grams. So that's 1 mole of iron is 55.845 grams of iron. And then we look at the second equivalent statement, our mole to mole ratio from our balanced equation. So there's 1 mole of Fe2O3 for every 2 moles of iron. And then the last step is the last equivalent statement, our molar mass for iron 3 oxide. So we have 159.687 grams of Fe2O3 is 1 mole of Fe2O3, or iron 3 oxide. Alright, so if we look at what we actually have to do here, we have 25, we're going to divide that by 55.845, divide that by 2, and then multiply by 159.687. If you don't like doing that, if that doesn't make sense to you, you can always multiply straight across the top and get a number, and then multiply straight across the bottom, get a number, and divide those two. But that's 3 different steps. I prefer to just do it in one, where I go anything that's on bottom I divide, like those two there, anything on top I multiply. So when you do this, you get 35.743 on the calculator, and then we need to do our significant digits. So there's 2 in this one, there's 5. Multiple ratios are always exact, and then this last number has 6. So our limiting significant digits is 2. The 7 rounds the 5 up, and this becomes 36 grams of iron 3 oxide.